Hey, Rachel. How are you? I am going to pull up a blank piece of paper and was hoping it really was going to be blank. But none of them are, unfortunately. So that I can work this out for you. Number 35 and counting the positive and negative zeros. It's just one of those things that I feel like is can be a little, maybe just a little trickier.
Can you hear me now?
Yes, I can hear you now.
Okay, I had to download the app and stuff on my phone because my computer broke. Sorry about that.
Oh, I totally forgot about that. You told me that yesterday.
Yeah, I was using my
Wow.
computer and it doesn't have a microphone, so I had to do that really quickly. I'm sorry about that.
Oh, no problem. Bless your heart. Oh, that's hard.
No, it's okay. I mean, I'll figure it out. But anyway, yeah, can you explain number 35 to me?
Yes. Um, okay, so the sign changes. All right, so what we're going to do is just count the sign changes, and that's going to be for our positive real ones. And so this is one sign change, and then there's no more sign changes. Okay.
Okay.
So that means there's going to be one possible positive sign change or sign change, real zero. Help me, Lord Jesus. All right.
Okay.
And then we know by this that there's a possible three total, right?
Right.
Okay. So now to figure out the negative, we're going to do g of negative x, which if we look at that, if you put in a negative into this, so you would have a negative, and then we have a negative x cubed plus 5 with a negative x squared plus 12. This would be, if this was a negative right here, that would be a negative x times a negative x times a negative x, which would still be negative. And then the negative times a negative would be a positive. So this would be positive. Does that make sense?
I think so, yeah.
Okay. And then here, negative x times negative x is going to be positive as well. And then this would be positive.
So there's
So
zero.
there's zero sign changes.
Okay.
So zero possible negative zeros.
Okay. That makes sense. I understand it now. I think I wasn't changing the negative with all the exponents. I wasn't doing that part right.
Oh, okay. And that is like, I just have to write it completely out and then like do that counting thing because that can get a little squirrely. I think. You know what I mean?
Yeah, that makes sense. And then can
And
you do 19?
19.
Yes, please.
Absolutely. Find all zeros of the polynomial function. And one final note on this one, since there was 3 total and there was 1 possible real zero and 0 possible of that, then you can think then that there could be up to 3 imaginary, because this are 2, this is 2 imaginary solutions. Does that make sense?
Yeah, I
Because
get.
2 plus, okay. I just wanted to make sure that we hit all the everything on that one.
Yeah.
And then let me go ahead and write out number 19. Did you graph number 19?
I did yesterday, but I'm gonna redo it so I remember how.
Okay. My graphing calculator, the screen went out on it.
Oh no, do you want me to graph it?
Well, yeah, because I was well, either that or I'll use Desmos. But I feel like I've like literally lost an appendage because it is very difficult to do polynomial functions without a graphing calculator. You know what I'm saying? Because even in like I can find the zeros on Desmos without a problem, but I can't do like, the trace function and all of that stuff. You know what I'm saying?
Yeah, that's hard.
Yeah. So I've got to, your computer's broken, my calculator's broken. We're limping along, Rachel.
Okay, I'm doing it right now.
Okay. 13x cubed plus 19x squared.
Okay, it looks like really weird because it like crosses like I don't even know how to describe it. I guess I can turn my like camera on and show you.
Yeah. Okay. Let me see.
Um,
Well, I was going to say it might be, I don't know. Okay.
um,
Can you, oh, yeah, it is. Can you tell at all where that's going? It looks like it's going through at least 1 on the right, is it?
I think it's going through 1 on the right, and I think it might be going through -3.
Okay. All right. Well, let's start with those.
Okay.
So we if those would be the zeros, it looks like 1 and 3 as possible zero. That looks like a coordinate. I don't want to do that. 1 and 3 as possible zero. I'm sorry.
I think it's -3 because it's on like the
Oh
negative.
yeah, I'm sorry. -3. You had said that. I just didn't write it down. All right, so we're gonna start. Actually, I'm gonna move that because it's gonna be. I'm gonna write it up here. With 1 and -3. And so 1 and then 2, 13, 19, -10. I don't need any placeholders, right? No. 4, 3, 2, 1. Yep, we're good. All right, so I'm going to bring down my 2, then multiply. 2 times 1 is 2. 15. 15 times 1 is 15. That's going to be 34. And 34 times 1 is 34. That's going to give me 24, and 24 times 1 is 24. Yay, it was 1. All right, so that gives us, this would then be x cubed, x squared, x by itself, and then my constant. So I'm going to use -3. Bring it down. 2 times -3 is -6. 15 plus a -6 is 9. 9 times -3 is 27. Oh, wow. Maybe it's not -3. You think it's a possibility it's not, or did I do math wrong? Oh,
No,
this is -27. There. And then, right?
yeah, I'm not sure.
So then that's going to be
But 7 times -3 equals equals -20.
21.
Yeah. So I guess
I knew my math didn't look right because it wasn't going to come out right. That's still not coming out right. Oh, wait. That was right. Ugh. Is that what happened to you?
I'm not sure.
Wonder if it could be something. It's not 4 by chance, is it? Or
Let me
can you tell?
look. 1, 2. It could
It's
be
so
4.
hard to read.
It could be 4.
You think it could be?
It might be.
2x. It is.
Okay, good.
Actually, and it looks like there's a -2 also. Desmos, it's just absolutely ginormous. So yeah, it looks like there's a negative. When you scroll in really, really close, it's like there's a -2 also.
Okay.
So I may try that negative. It's very hard to tell on the calculator sometimes.
Mm-hmm.
Unless I graphed it wrong. Let me double check everything. It is 19x squared, right? Minus 10x minus 24. Okay. So we'll try. Oh, that one is. Okay, so now I have, this should be 2x squared. So we could do a couple things. We could see if we can factor this. And we probably should be able to. Or you can use the quadratic formula.
So if I was going to use the quadratic formula, how would I do that?
Oh, okay. I was going to slide and divide, but I will absolutely. So you would do A equals 2, B equals 11, C equals 12. So the opposite of B, which is going to be the opposite of 11, plus or minus.
All right, so then you just do the quadratic formula from there.
Yes, ma'am.
Okay, and then if you're going to slide and divide, then what would you do?
And sometimes this can be risky because, you don't know for sure, if it's going to come out even. And absolutely, the quadratic formula, it works every time. So I'm going to look for factors of 24 that add up to be 11, which is 8 and 3, x plus 8, and x plus 3. And so then here's where you slide. It's called slide and divide, and this is where you divide. Okay, so I'm going to divide both of those, and this comes out to be pretty. So it's x plus 4. This one not so pretty, so you bring your 2x plus 3 over. So that means my other zeros. So I could tell by the calculator that 1 was a 0 and -2 when I got it in Desmos. So this is going to be a 0, and that's going to be -4. and this is going to be a 0, and how you would find the actual 0.
Okay.
And x equals -3/2.
So in my work before, like for this whole entire chapter, I haven't been using slide and divide. So should I be using that when I'm factoring?
Okay, let me tell you how I knew I could use slide and divide on this one. When I graphed it in Desmos, and I don't know if you've ever used Desmos or not, but when you get a computer that works, again, it's desmos.com. You can set your, maybe I could actually, I graphed it on my other computer, but I could show you this. But I could see that it hit the x-axis at very exact points. You know, it wasn't going to be something like there was an imaginary or whatever. If I were you, if I got something, I would probably stick with the quadratic formula. I could tell by graphing this that I was going to get very solid points. So slide and divide was going to work. Does that make sense?
Okay.
Like get some really whole integers or things that look pretty clear cut, or at least 3 of 4 are pretty clear cut, then I know this slide and divide is going to work. When you're going to end with imaginary or irrational, then that's when you're going to use the quadratic formula.
Okay, so but generally if I'm doing these problems, I should just use the quadratic.
Yeah, I would. You know, unless you got something that was just so straightforward, like, you know, something really, really simple like x squared plus 4x plus 4, you know, something very straightforward where you can almost look at it and factor it. And I don't know where you are with factoring. Like if you had just this, you know, and you hadn't had to slide and divide, but your actual answer turned out to be x squared plus 11x plus 24, I can look at that and see that it's easily factorable. I don't know where you are in the factoring sense. Do you know what I'm saying?
I'm terrible at factoring. So I'm bad
Oh,
at the entire chapter. I don't get it at all.
oh, I'm so sorry to hear that because I just perceived that your questions in class are very, you know, they're very insightful. So I was feeling like you were really understanding.
No, I just don't get it. But I'm trying to understand. So
Yeah. For me, you know, like I guess probably because I've been doing it for over 30 years, factoring comes almost second nature to me. So I kind of perceived that in this slide and divide that I might get a fraction, for which I did. But you know, they're not, it wasn't going to be that bad. But when I look at a graph and I see that it's going through the x-axis at very clear, relatively precise points, I know that I can probably factor it. Does that make sense?
yeah.
Because all of these factors are where it crosses the x-axis anyway.
Okay. And then
Like,
really quickly, can you just explain to me how to factor a quadratic equation? Because I still don't get that either.
oh, the ones that are in quadratic form?
Yeah, that's what I mean.
Okay. All right. Yes, absolutely. Do you have one handy that is in quadratic form? I mean, I can look one up in just a minute, but I didn't know if you
Yeah, I don't
had
have.
one. Or is the form itself a bit confusing to you?
Yeah, I just don't get the form. I don't have a specific, but I want to know how to do it before the take home quiz.
Okay, I got you. Let me look one up real quick then. I guess there's really no such thing as quick when it comes to technology, is there?
Yeah, that's okay.
There we go. It's I hope thinking if you can without me writing anything at this point, let's just think about a quadratic. The very first term is the very first term is a squared, and the middle term is an x to the first. So if you can kind of wrap your mind around the fact that x to the first, even though we don't show that exponent of 1, it's half of 2. So when something is in quadratic form, it means that your first exponent is going to be like 4, and your second one would be 2. Does that make sense? So it's that second term, the exponent is always going to be half of the first.
It always is.
So that would be how you would know that it was in quadratic form, is if the first term was the exponent was half of the second, and there's nothing in the middle. So like if you were doing one that was 16g to the 4th minus, and I'm just going to do, okay, 625. And I have no calculator, so this is going to be cute. 625, the square root of that is 25, right? Okay. All right, this is in quadratic form, but it's actually also 2 perfect squares. So the square root of 16g to the 4th is 4g squared. Plus 25, because this is the difference of 2 squares. Did that part make sense to you?
I guess so. So whenever you're doing this, you always square root it first?
Yeah, well, yeah, I need to find yet another example of it too.
Okay.
This is the difference of, I'm going to do a couple examples, 2 squares. All right.
Okay.
This is one where it's a difference of 2 squares because you've got that g to the 4th. All right. So this then can be further factored because this is the difference of 2 squares.
Yeah, I don't get why you only do that to one of them. Why don't you do it to both of them? That 2g minus
on the squares, when it's the difference of 2 squares, the difference part is because this is a minus.
Oh, okay.
This is a plus. And it won't work. And if you kind of how we know this, like let's just break this down. If I did 4g minus 25 equals 0, I could actually add 25 to both sides, right?
Mm-hmm.
And then I would get 4g squared equals 25. Then I would divide both sides by 4, right?
Yeah.
And then I can take the square root of that.
Okay.
And it would be okay. But if I did that on 4g squared plus 25, I would get 4g squared equals negative 25.
Oh, okay.
And so then I'm going to end up with an imaginary, which really in this unit is okay because I can have those imaginary zeros, right?
Right.
But as far as factoring is concerned, you wouldn't have that perfect square. Okay?
Okay.
That's why learning some of the patterns is important. When I was showing like the difference of squares, but you can do it with a cube because you can get the cube root of a negative, right?
Right.
Okay. So, I don't know. I'm gonna try to make one up that's in quadratic form where it's a fourth, and now it won't erase. Come on, please erase. I'm kind of starting to think that maybe my stylus has worn out after several years of math lab.
Oh no.
Because I'm struggling with getting it. I'm going to try to look for some more quadratic forms. Here we go. Here's one. Three, and I'm going to even slide and divide on that one. I don't know if that's going to blow your mind or not. Since you're not a fan of factoring to begin with, you may hate me forever. Okay. On this one, this is a quadratic form because the first term is 4, the second term is 2. Thereby, the first and second term are half of each other, just like a quadratic would be.
Okay.
Okay. So what I'm going to do, slide and divide.
Can you do it without doing slide and divide?
Yeah, I would be doing, you could do the quadratic formula, I guess, and just pull your coefficients. Would you rather do that?
Whatever the way we're supposed to do. Like, I don't know. This is confusing because there's certain ones where you do it, and I don't know which ones you do it and which ones you don't. So
I'm absolutely positive this is going to come out with regular factors, like easy factors.
okay.
So that was the only reason I was going to use it. Maybe I should. I know. You did this one on homework, so I kind of hate to repeat it. I was trying to do one that you didn't do on homework, but I'll just do both. A to the fourth plus 7a squared. Once again, the first term being half of the second, right?
Mm-hmm.
Okay, so what two factors multiply to give me 6 that when I add them, give me 7? Well, that's 6 and 1. Oops, that was supposed to be a plus sign. And that equals 7. Because 2 and 3 are also that, but that gives me 5. So I do a squared plus 6 and a squared plus 1. So it's the same exact thing, except for here and here, I have to do the a squared as opposed to just a plain a.
Okay, and then that's the final answer?
For this one, that is the final answer. If by chance I had gotten a squared minus 1, that's a difference of 2 squares, so you'd be able to factor a little more.
Then what would you do for that?
If it was a squared minus, like, let's just change this for a second. Let's change the problem to be this. So then it would be a squared minus 6. And then this would be the difference of 2 squares.
Okay.
And the other one I really can't do anything with. This would be irrational.
Okay.
Because it would be the square root of 6.
Oh. Okay.
So basically, we would have, how it asked for the rational zeros? So you would have a equals plus or minus the square root of 6 as a 0, and then plus or minus 1. Those are your 4 zeros of this quadratic in quadratic form.
Okay, so what if it was like a squared minus 4? Then would you have a, like, would you have a plus or minus plus 2 and then a minus 2?
Yeah.
Okay.
Hey,
So
I got one that we can make up that would go well with that. Hold
okay.
on just a minute. I can do that for you, Rachel.
Thank you.
I can make that happen.
Thank you.
So hopefully that, it will help. Great questions. That's why I said your questions are very insightful.
Oh, thank you.
So, okay, so we've got minus 5a squared plus 4. So, the two factors that multiply together goodness gracious, multiply together to give me a negative or positive 4, but add to give me a negative 5 are negative 4, negative 1. So I've got a squared minus 4 and a squared minus 1. So now both of those are the difference of two squares. So they would be a plus 2, a minus 2, oops, a plus 1, a minus 1. That's the factors. But that tells me that this quadratic, if I were to graph it, it would go through 2, negative 2, 1, or negative 1 and 1 on the graph. And that's in quadratic form. Quadratic form says the first term is half of the second.
Okay. And then what about if you have like your first term is like a to the third? Then what would you do?
If it's a to the third, you're going to go to where I would now graph it and see if there's any possible zeros that you could identify. You know what I'm saying? So now that you've been taught that in 2.7, I would definitely graph it first, see where it crosses the x-axis, because remember, zeros, roots, and x-intercepts are all the same. And I would see if there's one that where it actually crosses the x-axis, and I would start there and then do synthetic division. And once you've done it and it's a to the third, it would, and you did synthetic division, your next, once you divided out that first 0, it would put it in quadratic form. And then you could either factor or use the, quadratic formula.
Okay. All right. I think I understand now.
Okay, great.
Thank you.
No problem.
Thank you. Bye.
Have a blessed day.
You too. Bye.
Bye. Hey, Christian, do you have a specific question?
Not right now. Just working through them right now.
Okay.
Getting it in.
Okay, good. Are you on 2.7 or are you working on a review sheet?
I am on 2.7.
Okay. Because I think I did, I don't know. I think I did 35 earlier. Did you make it in time?
I do not think I did.
Okay. Well, I had done 35 earlier. Let me see if I can find it.
Well, those are fun.
Yeah. Yes. Aren't they though?
Yeah.
Which one are you on now? What number?
I am on 11. I'm just double checking my work actually right now.
Okay. Okay, so just asking kind of some probing questions. Are you trying to graph them first?
I am not.
Okay, that is a good thing to do. And let me show you why. Because on this particular unit, my graphing calculator died, by the way. I don't know if you got here in time to hear me moan and complain to sweet Rachel about my graphing calculator, but the screen on it died. I have no earthly idea why, and I'm extremely sad. It is very difficult to do polynomial functions without a graphing calculator, let me just say.
Yeah.
So I'm going to graph 11. And we're going to, can you see my graph?
I can.
Okay. Now I'm just double checking to make sure I typed in everything correctly. Oh, it is an ugly graph. Okay. So the reason why you kind of want to graph it first is, see how my dots kind of showed up there? Pretty dots. See how that showed up? There's a 1. So it definitely crosses through 1. Okay?
Yes.
Make sense?
Yeah.
All right. So what I'm going to do then is I know that that's one of my zeros. So I'm going to go back over here and I'm going to do x to the 4th plus. So what you want to do on these polynomials is find as many zeros through your graph as you possibly can. Okay? Especially when you're getting down to where they're asking you to find all the zeros. See, and that's what the instructions say, find all the zeros. So where they're including the irrational and the complex numbers as well. So when you find one where it looks pretty and it's going through, because the other ones are not as pretty. See?
Yeah.
That's 1.839. Oh, that's not even 1. So my bad. So, so this other one is a real funky looking number. Okay. All right. So we've got one pretty one funky looking one, but as we learned, there's 4 zeros because that exponent tells us there's 4 zeros. So on there, I see where I've got one pretty one, which was the number 1. So that tells me that the others aren't going to, it only passes through the x-axis at 2 points. One is pretty, one is not so pretty. So the other 2 are going to be imaginary. Does that make sense? Or clear as mud?
Yeah. Yeah, it makes sense.
Okay. So to find all of the zeros, I'm going to use the one pretty one because that's the one I want to work with. And thank God, it's a 1. Can we just praise the Lord for a minute about it being a 1? Because we can all handle multiplying by a 1, right? Maybe no, obviously I can't because I just didn't do it right. So anyway, 5 plus 1 is 6. 6 times 1 is 6. -7 plus 6 is -1. -1 times 1 is -1. -29 and 30 is -30. -30 times 1 is -30. And then that's a 0, which is what we were hoping for the whole time. So that tells me then we've got x cubed plus 6x minus 1 minus 30. Right? Is that what I did?
Yeah.
Okay. Oh, and the other one is ugly. I don't like that. No, it's not. Is it? Yeah, it is. Ooh. Why? Why did they do that to us? Oh, wait. Because Miss Sparks didn't type it right. It
Yeah.
helps you type it right.
Mine were all pretty normal so far.
Well, one was one.
I had -5, -3, 1, and 2
For that one?
for that one as my 4 solutions.
So did I type it in the graph right?
You just did. Did
No.
you?
No. So yours were all normal.
Yeah. I didn't have any irrational for number 11.
Oh, okay. They were all pretty.
Yeah.
Yay. Okay. Okay, so did you just go through and use all of your x-intercepts then?
Actually, I did
Is that
something.
how you did it?
I just factored it
you
over and over again until I got it into simplest form.
Oh, you did?
Then I had all my factors.
Okay. Well, on that one, you actually could have just used the graph.
Yeah.
Or did she want you to show work?
She wants you to show work.
Oh, okay. So but you could start with one of the ones that you got from the graph. She was good with that, right?
I believe so.
Okay. Because that's what I was telling my students at this point. It's like you kind of learn the hard way and then you go through and it gets a little easier. But I was thinking, yeah, I did this one in class yesterday, I think. So, just like the video. So you got that one done. Your
Yeah.
goal.
Yeah. 13, I believe, is a pretty one too. My
It is pretty?
calculations, right? -5, -2, and 2. And
Yay.
I'll graph it to check.
Yeah, they are this one. When you get down to this point, Christian, are you just factoring
Yeah.
and not using synthetic division? Is that what you're doing?
Yeah, I'm just like factoring completely.
Okay, so once you get it to quadratic form, are you just factoring like that?
Once I get it to quadratic form. Wait, let me see.
Like this.
Yeah.
This is number. Yeah, okay. All right,
That's
good.
how I'm finding the solution.
So you're just using synthetic division till you get it to the quadratic form?
Yeah.
Oh, cool. Good job. Way to go. All right, when do they start getting ugly?
It looks like 15.
Oh, okay. That's why they circled that one and put it in the back of the book. Right?
Yeah.
That red circle means that it's worked out in the back of the book for you.
Ah, lesson learned.
Yeah, isn't that great?
Yeah.
And they typically will do that when they make that first one harder. They'll typically do that. You know it's going to take a turn when there's a red circle.
Yeah.
It's going to take a turn, but they're going to at least show it to you. But I'm happy to work that one out if you want me to.
Yeah, I think we'll do that one because that's the one I'm on now.
Let's do this. X to the fourth plus X cubed. Has anybody else showed up for math lab?
No, I don't see anyone.
Okay. Now I'm just double checking to make sure I wrote it right. And then I'm going to go over to Desmos and graph it so we can get our first.
Yeah, this one looks super not pretty.
Super not pretty? Oh, no. X to the fourth plus X cubed plus 2X squared let's double check. X to the fourth plus X to the third plus 2X squared plus 4X minus 20. Yay! I graphed it right. Oh. Right. It is super not pretty. Surely there's one pretty one.
There is one, but it doesn't look like it's on there. Yeah, there. That looks right. Because positive 1 is a pretty one and negative.
Yeah. And it looks like, what is
two,
this one? Is
pretty one.
negative 2. Okay, well, let's start with 1. 1, remember our favorite number. So 1, and then we'll work with negative 2. 1. Which way did you start? Maybe I should start your way. What did you start with?
I started factoring. So I started by grouping the first two terms and then removing x cubed. And so it's just x plus 1 times x cubed. And then I took my last three terms and used the AC method to get to be able to factor.
Oh, look at you being all creative.
Yeah, I do them different.
Well, that's cool though. Okay, I'm gonna try that in a minute. But I'm gonna do synthetic on here. You keep working your method and let's see what we come up with. I love that. So what you've done is you've taken everything that you've learned and just kind of worked your way around doing it all kinds of different ways.
Yeah.
That's amazing. I love that.
Yeah.
Then the other one that we came up with was negative 2, right?
Yeah.
So that's going to be x squared plus 4. That's what we end with. And what's going to happen there, you set that equal to 0, you're going to get x squared equals negative 4, which that tells me if you take the square root then of both sides, we've got plus or minus 2i.
Yep.
So the zeros are 1, negative 2, and plus or minus 2i. And that's what you got?
Yeah. Yeah, it took me a while, but I got it.
All right. I can hardly wait to try your way. I love that. So you ended, so that would have been x squared.
So essentially, like to start out, you take the first two terms, and then, so because it's just x, 1x to the fourth and 1x to the third, I just take out
X to the third, so you have x plus 1.
Yes, and I know 1 is a factor now.
Okay.
And
then you would have factored out the 2 out of there, and you would have x squared plus 2x minus 4.
Yep.
So then you could have used the quadratic formula on that.
Yeah, and then you find out it's plus or minus 2i, which is an odd answer, but it works.
And then you would have had x plus 2 as your final factor, because once you factored the x out of that. Okay, cool. I love that. That's so interesting.
Yeah, it's just how my brain works on them.
Well, I love that. That's really taken everything that we've learned in factoring in the first couple of chapters. So is that pretty much how you approach factoring every time?
Yeah, that's how I usually start them that way, and if it gets like super ugly, then I'll double check my work afterwards, but usually it works out okay. I mean, the only bad ones, so to speak, are when you have to use the quadratic formula, which isn't that big of a deal.
Yeah. I get what you mean by starting to factor then. All right. Do you want to do 17 and 19 together, or do you want me to show you how to do like 21?
I'm working on 17 right now, if you want to do it with me.
Okay.
Okay. So I just took x cubed out of it. So I have x cubed and then parentheses x minus 2. And 3 and 2 is 6, which is 1.
X to the fourth minus 2x cubed minus 3x squared plus 2x plus 2. All right, I'm just looking for my pretty ones. That's not pretty. That's pretty.
You should have a 2 in
-1.
Do you not have a 2?
I don't.
Let me make sure you wrote it exactly right, because I could be wrong. Minus 2x cubed minus 3x squared plus 2x plus 2. Well, would you look at that? Huh.
All right.
What did I do wrong?
Well, I'm going to approach this with synthetic, and I know that I got 1 and -1. So that's how I'm going to start. I know these two are 2 of my zeros. So, but you keep working, because you might find, because this one, it looks like you would have had to pull a negative out. So that might change things for you.
Yeah, actually, I have to run. Well, we know it's imaginary, because there's one that I can't factor any further. It has to be run through quadratic.
Okay. Yeah, that I was going to say, because you ended up with, you should have ended up pulling a negative out. The -1, there should be a -1 that you pulled out, and that's going to be tricky here your way when you're grouping.
Mhm.
But I can show you how to do that. I'll write it out and give it to you tomorrow since you need to go.
I do?
Oh, I thought you said I have to run. I thought that meant you had to go.
No. Nope.
Oh, all right.
I said I'm running with that one,
Oh, okay.
but
My
I hit a speed bump. So
one. I may have hit a speed bump too. Nope. No, I'm good. So far.
yeah. So now that brings us x to the third, and then that would be x squared, and then that would be x, and that would be our constant. So there we go.
So then that has to be, we have to use the quadratic formula.
Mm-hmm. What'd you do with your x cubed term?
I'm just used synthetic division all the way
Oh,
down.
you did it again. You did it
Yeah.
again. Now I see.
Yeah, I did one and then I did -1 because I saw that those two were on the graph. So I used the zeros that came from the graph, and then and that brought me 2 zeros, praise the Lord. And then now I'm running this through the quadratic formula, as you were saying.
Mm-hmm. So is root 3. Yep. There you go.
So my zeros are 1, -1, and 1 plus or minus √3.
Mm-hmm.
Is that what you got too?
Exactly.
Cool. Now, I want to go back up here and I'm going to try to do it your way.
Mine, you actually only got one step down before you hit a speed bump and you can't factor it any further. So this, I actually ended up changing it to this way.
Oh, you did?
I
Okay.
did. I changed midway.
Okay. Well, that's okay. And the thing about it is that you're experimenting with all the things that you tried, but I think I can figure out where the speed bump was.
Yeah, it was actually pretty early on. Once you got to -3 plus
Yes. And I
2
feel
plus
like that
2.
-3 was the speed bump because I
Mhm.
think if you would have done it this way.
That's exactly what I did. And you remove x to the third, and then you get x minus 2, which is why I didn't understand why there wasn't a -2, because that's clearly a factor. Maybe it runs away at the end.
Maybe it does. I don't know. That's interesting.
I think my guess is that if you were to factor down, which I didn't because I realized the other method is going to end up being easier. But if you were to factor it down, my guess is there was another x plus 2 and they would just cancel out.
Yeah, maybe that's it.
Because you do get that sometimes, but And then I took the factors of AC, which ended up being 6, which is interesting because I couldn't find a factor that added up to 6. Added up to -2.
I'm gonna keep working on this for just a second. No. So you would definitely have to quadratic formula that.
Mm-hmm.
Yeah, I don't know. It's interesting. That was a hiccup. It hit a hiccup, like you said.
But that's why there's not just one method to solve it.
Yes. So that's why typically I like to graph first and then get myself off, like, oh, okay, well, then I know that this and this is going to work. Because, I highlighted all of these. You know what I'm saying?
Mm-hmm.
And so those were crazy looking.
Yeah, sometimes you get wackadoo ones.
Yes, you definitely do. So 19.
Yes, that is 2x to the 4th plus 13x cubed plus.
Are you graphing this one?
I'm gonna see if you can do it without, and then I probably will end up at graphing 10x minus 24. Just one more thing. So we'll take that, and oh, this is not going to be a pretty one. I can tell from step 1.
Yeah, it does look a little ugly.
Our first factor is 2x plus 13.
Yeah. Not so pretty.
Yeah. I'm going to have to do synthetic division on this one.
And let's see, we got a 1, 1.5, a 2, a -2, and a -4. So we have 1, -2, and -4. Actually, it should turn out to be all factorable. It looks like all four zeros hit the x-axis.
They do.
So it won't be that bad. It only appears ugly.
Yeah.
2x to the 4th plus 13x cubed plus 19x squared minus 10x minus 24. So I'm going to do synthetic and reminding myself that my zeros, I had a 1, a -2, and a -4. Those are going to be the easiest ones to start with. So -1, and then 2, 13, 19, -10, -24. 2 times -1 is -2. 13 minus 2 is 11. 11 times -1 is -11. That's going to be 8. This is going to be -8. That doesn't turn out. Why? Oh, because it's a +1 and I did a -1. That's why. It always helps if you plug in the right number, Christian. You know what I'm saying?
I do. I have found that to be helpful as well.
It's a lot of work to plug in the wrong number on the first step. You know what I mean?
I do.
And the worst part about this is I've done this one already. This is the 3rd time I've done this problem. And I plugged in the wrong number. Please, Lord Jesus, help Mrs. Sparks.
Yeah, that works out.
Yes, much better. Don't you think? Much better.
It does.
So
We might-
now let's just double
Now we
check and make
take
sure I
out.
plug the right zero. Let's do -2.
Yeah, negative
Just
2.
combine my -2 and my +1, I guess. So -4. Hold on just 1 minute, Christian.
No problem.
Hold that thought.
So it didn't come up with that good of an answer. So
Oh, okay. No problem. Mackenzie had accidentally turned on the feature on the on her Chromebook where it talks to you, and everything that you type, it literally says what you're typing. She was like, "Make it stop." So I had to Google real quick how to get it to stop. Has
That's
that ever
awesome.
happened to you?
It has.
Oh,
I've done a lot of things on my Chromebook that shouldn't happen.
yeah. He says a lot. He says I've done a lot of things on my Chromebook that just shouldn't happen. She said her too. Okay, so now we have 2x squared plus 11 plus 12. So
you have to use quadratic on this one.
yes.
I'm pretty sure.
Are they pretty numbers?
It should work out. They were pretty numbers on the graph, but I guess you
Okay, well, I'm going to do slide and divide then.
What's that? Do not know slide and divide.
Slide is here, so I slide down my 2 to my to my 12 to make it 24. And now what two numbers give me 24 multiplied? So here's my multiply column, and here's my add column. So what two numbers, and I kind of know those like off the top of my head, that's going to be 8 and 3.
Yeah.
They multiply to give me 24, but when I add them together, they give me 11. So now I've got x plus 8. X.
Totally overlooked that factor.
And so then I have to do my divide part because there's where I slide. And now here's where I divide. Okay, so that's why it's called slide and divide. So you take your original leading coefficient and you divide that. So this, if it divides pretty, you get to write it out pretty. If it's ugly like that,
just make a fraction.
Yes. And here's the other thing that you can do, really, in all honesty, because this 3/2 right here is really the 0. The -3/2 is the 0 because you and I both know that one of the zeros is -1/2 from our graph. So it's -4, 1, 2, and 3, and -3/2. So you really don't even have to do the divide part unless it's asking for factors. If it's asking for a 0, you can literally take this part and make it a 0. Does that make sense?
Yeah. Yeah. Would it be -2?
Yes.
Awesome. Okay, making sure I did it right.
You did. You're absolutely right. -4, 1, -2, and -3 halves, or -1.5, whichever way you want to write it.
Alrighty. 21 looks fun.
It does?
I don't know.
Oh, yes, it does. I love 21.
So,
Okay, so on this one, what we're going to do is on all of the previous ones, we've been given the polynomial, and we have to factor and divide and do all those things to get the zeros. Well, now they're giving us the zeros and asking us to write the polynomial. So we're going to do what we've been doing in reverse. So what we want to do is take those zeros that have been given to us in number 21, and the zeros are -2, 1, and 3. And what we'll want to do is write those into factors. And to do that, you do the opposite of what it is. So for that -2, that's going to be x plus 2. Okay? And I'll prove to you why if it doesn't make sense.
No, I understand that. So it's x plus 2, x minus 1, and x minus 3?
It is. You are on fire.
All right. I hope not.
Okay. So then you'll just go ahead and FOIL and then distribute.
Oh my goodness, that's so easy.
Okay, so which two factors do you want to start with to FOIL?
I'm starting with x plus 2 and x minus 1, just
Okay,
because
so-
they're the first two.
Okay, x squared plus 2x minus x minus 2. And then you combine your like terms. So x squared plus x minus 2. So that becomes a term. I'm going to bring my other term down, x minus 3. And you have to distribute your x to everything inside, and then your -3 to everything inside. So x cubed plus x squared minus 2x minus 3x squared minus 3x plus 6. And then you combine like terms. I don't have another x cubed, but I do have a positive x squared, and I've got a -3x squared, which would give me a -2x squared. And I have a -2x and a -3x, which gives me a -5x plus 6.
And then is that it?
Yep.
Awesome. That
That's
wasn't that bad.
No, it's not bad at all.
Cubed minus 2x squared minus 5x plus 6. 23. I need a new sheet of scratch paper. 23.
Yeah, I would imagine these take a minute.
That would be x
They're
plus
not. It's not hard. It's just can be a little time consuming.
minus 4 and x minus 6. Okay.
Have you seen my other black school bag by chance? The little one? Oh yeah, here it is. It was right next to my chair. I couldn't see it. Do you want to see number 23 written out, or do you want me to just confirm that you got it right and we'll move on to 25 because it's got the imaginary number in it?
Actually, we only had to do 3 through 23 odd.
Oh, okay.
And then 35 through 41 odd.
Oh, okay. Because I think I added number 25 to my students because I wanted them to handle one imaginary one. I was mean. So you can thank Miss Wynn for not being as mean as Miss Sparks tomorrow. So do you want the answer to number 23 to confirm that you got it right?
I am actually not done with 23 yet. I am in the process of distributing my -6 right now.
Oh, okay. I got you.
6x negative 12x. And that'll just be positive 3 times x cubed minus 4x squared minus 15x plus 18. Does that sound good?
It is perfect.
Awesome. All right, and now to 35. What even is 35? Determine possible. Oh, these are easy. I love these. Imaginary. So how would you work out 35?
Okay. 35 is going to be where you use Descartes' rule.
Yes.
Okay, so it would look like x. Let me write it down. So because I think it'll make more sense if I have it written out. G. Well, heavens to that. G of x equals negative x cubed plus 5x squared plus 12. Okay, so what you're looking for is sign changes. So the sign changes there, that's 1. But my sign does not change from the positive 5x to the 12. Okay?
Yeah.
There's only one possible positive solution. All right?
Mm-hmm.
And now for the other one, g of negative x, it's going to look like the opposite of negative x cubed plus 5 negative x squared plus 12. So if I do negative x times negative x times negative x, I'm still going to have a negative x.
Yes.
And if I take negative x and multiply that by a negative, I'm going to end with a positive.
Yes. That would be x cubed.
So then over here, if I take negative x times negative x, that's going to be
x.
positive. So this is going to be this, 5x squared, and this is going to be this. There are no sign changes. So there are no possible negative solutions. But if I look back and I see that my original exponent was 3, I know that I'm supposed to have 3 zeros.
So that means there's 2 non-real.
Yeah, there's 2 imaginary. Yes. So 1 positive, 0 negative, and 2 imaginary.
Awesome. So 37, that is 1.
That's a humdinger.
2 sign changes. There's 2 positive.
So that means you have to do 2 or 0 because you have to count down. you have to subtract. The possibilities go in like descending order by twos. Okay. So if there's two possible solutions, you can subtract 2 from that. So there's 2 or 0. So this is where you kind of have to set up that chart. Like, did you see the example in the book where there was a chart?
I did not. We haven't gone over this in class yet. We were just working on it. And then she's going to have it come and see if we were able to do it and then check our work, and then we'll work through it all together.
Okay.
So it's 2 or 0. Well,
Yes.
we know how many there are, so can we figure out whether it's 2 or 0 at the end of it?
Well, you do a little chart, and I'm just going to have to show you the chart.
Okay.
I don't know how else to explain it.
All right.
I'm going to show it to you. They do a good job in the book, so I'm just going to show it to you, and then you decide what works for you.
All right.
And we'll make one like the book as well. Plus 6x plus 5. Okay, so like you said, we go from here to here. That's 1. That's not a sign change, but this is a sign change. So there's 2, and then or 0 positive solutions. Okay, and now h of negative x equals negative x to the 5th minus 2 times negative x to the 3rd, right? Times minus, and then negative x squared plus 6 times negative x plus 5. So this is going to be negative x to the 5th. This is going to be negative 2 times a negative x. So that's going to be a positive 2x cubed. This is going to be negative x squared, which would make that positive. And then that's going to be a negative x squared. And then this is going to be a negative 6x plus 5. So my sign changes are from here to here, here to here, and then there to there. So 1, 2, 3. So 3 or 1 negative sign change. And I think I've written too big to make myself my chart, but we know that there's a possibility of 5. So let me go to the book and show you kind of how they do it. And then we'll kind of build our own chart for this based on the example. Because I feel like if I show you the example first, when I'm building this chart, it will make more sense to you. You know what I'm saying?
Yeah.
If you see it and then we work on it. Well, where's my pretty little chart? Here she is. Okay. So they came up with this chart that kind of, you have to, at that very final row there, you need to have your total zeros with all of the different possibilities that could possibly happen across the rest. Okay. That's kind of how they built it. So you can see that. But based on what you were saying, if we take 2 positive zeros and 3 negative zeros, then there would be no imaginary left, right? So if we have our chart, And then we say positive, negative, imaginary, and then total.
Mm-hmm.
We know that this is supposed to be 5. So if we have 2 positive,
Mm-hmm.
3 negative, that would be 0 imaginary.
Mm-hmm.
But if we have 0 positive, 3 negative, then we would have 2 imaginary.
Mm-hmm.
All right.
Yes.
So have we used all our possibilities yet? No, we haven't.
No.
Because we have 2 positive, 1 negative, then you would have 2 imaginary.
Mm-hmm. And then 0 positive, 1 negative. That would be 4 imaginary.
Yes.
So it's 0. It's 4, 2, or 0 imaginary.
Yes. Good job. Good job. So I mean, you could probably figure out another way to do it. I just felt like the chart was a good way to kind of explain how you do. You know what I mean? To have
Yeah.
more of a visual of how you calculate the numbers.
Got it. Okay, what do I
How far did you all have to work?
through 41.
Okay.
So 2 left.
Okay.
So 3. Actually, 39 worked just like the flip of 37.
Oh, really?
Yeah, so it's 3 or 1 positive, 2 or 0 negative, and then 4, 2 or 0 imaginary again. Because you can't, like, once you get your positive and negative integers, you can't have anything except 4,
Oh,
2,
there
or
you
0.
go. All right. Good
Because it's
job.
the same chart, just flipped.
Okay. Oh, I see what you're saying. Okay. Yeah. I have it worked out on another piece of paper, so. So that's good. So you're understanding this okay.
Yeah, it makes sense.
All right, good. Do you have any other questions for me?
I do not, actually. I think we're pretty good. Thank you.
No problem. No problem. You have a blessed day.
You as well.
Thank you for
Bye-bye.
showing up to Math Lab.
No problem.
Take care.
You too.